Welcome to SeaSync. My name is Chuin. My teammates are Guang, Yikai, and Eugene. And we are doing a 6G-enabled IoT smartwatch, which is a hybrid acoustic optical solution for diver safety. Now, let me have a little bit of background for this. So, 6G applications in the underwater world currently, we have underwater wireless sensor networks, which monitor climate change, oil leak, and also marine life, as well as 6G is used for visible light communication, where it is applied for rapid pulses of light to send data underwater at high speeds, as well as deep sea exploration, where ocean floor exploration can happen with a 3D mapping, and then it's a wireless transmission to ships on surface in real time. And next, we talk about the air-water interface, which 6G acts as a surface gateway to transfer radio signals from surface to acoustic and optical signals in underwater, and also seamless stitching, where the drones on the surface can be connected using 6G to ensure stable connection. Next, we see that it has some risk of isolation. And so first of all, we talk about the operational isolation, which is the loss of connection in storms. And then 6G can help us to stay in contact, as well as the cyber isolation, where 6G builds security directly into ship networks to prevent digital attacks.
All right, so when we look at the problem closer, we can see a huge technological gap between professional and civilian grade technology. As you know, commercial divers still operate in high risk condition, except they don't have the access to advanced health tracking technology as much as government or military grade funded projects. And existing communication methods underwater still have low bandwidth and high latency, which causes health data to be transmitted slow and congested, which can lead to life endangerment. And as of right now, commercial smartwatches still do not have live tracking underwater. So our objective today is to develop a continuous health monitoring and live tracking system where we continuously monitor critical health parameters such as your blood oxygen level and body temperature, as well as implement live tracking system with 6G low latency, as well as accessibility to high reliability technology, so that we can miniaturize, civilianize, and scale professional grade technology for commercial use.
So now I'm presenting our design for our SeaSync Smart Watch. It is a compact wearable device that uses ECG and PPG to measure the heart rate and blood volume. Besides, it also uses the hybrid transceiver for location tracking. So next, this is our hardware design for our Smart Watch. It consists of a compact and custom PCB featuring on FPGA and use the AMO LED. Next, we also use the sensor array that integrates different sensors. For the power supply, we use the lithium-ion battery with BMS. For the outer surface, we use the titanium and sapphire crystal construction. Next, for our strip design, we integrate the MCU and the sensing method for the signal transmission. For the waterproofing part, we use the O-rings. Next, this is our flowchart. The watch is contact away. On the surface, it uses the standard GPS and 6G. Once submerged, it automatically switches mode. It detects the distance to the surface station and select the best and next signal. And if it is near, it will use the optical signal, or else it will use the acoustic signals. At the same time, it will also transmit the data of the heart rate, blood volume of the driver to ensure real-time safety tracking at all times. So in the next slide, this is a short demo for it.
Now we are entering a rapidly accelerating market for connected diving. While traditional hardware is steady, underwater wireless communication is true growth engine, projected to reach $4.76 billion by 2032. Our 6G wearable targets two key segments: 6 million recreational divers needing proactive safety, and military sectors requiring secure anti-dirt navigation. So next, we shift from individual monitoring to long-distance team tracking. We don't just sell watch, we sell connection that ensures the surface always know your location. Okay, next. We replace the reactive alerts with proactive AI that predicts narcosis and panic before they happen. 6G digital twins enable remote intervention and continuous tracking, turning search into instant retrieval. Okay, for SDG 14, we bridge the data gap by using divers as a mobile sensors to crowdsource environment data where satellites cannot reach. For SDG 9, we establish the IOUT, providing digital infrastructure for sustainable mariculture and subsea management. And for finally, SDG 3, our predictive monitoring reduces fatalities and provides critical biological data for medical research. So now we have the research evidence, and what we're waiting for is time to sing or swim.